Okay, so with most of these visualizations, we've just been looking at kind of one variable at a time. So the most commonly spoken language, whether you say pop, Coke, or soda, the number of COVID cases or the rate of COVID cases. So we're sort of doing the geographic location as kind of our X and Y variables, and then we're just plotting one variable on top. What if you wanted to visualize more than one variable on a map? I love Jim Vladingham has this piece about multivariate maps where he has a ton of examples, and he highlights some strategies. So one would be to make sort of a 3D map. So this one is showing median rent based on the height of those sort of cones that are sticking up from different areas. And then the color is the percent of income spent on rent. So this is allowing the designer to visualize two variables at once by using kind of a 3D situation. This is another approach with median household income, where they are showing, I think this is actually kind of double mapping. So the height is how expensive it is, but then the color is also how expensive it is. So maybe that's not really visualizing more than two variables. Another strategy would be to include more colors. So this is a map that's trying to show the relationship by the percent of people who are covered by the Medicaid program and the percent of people that voted for Trump. So it goes from gray, which means very low percent covered by Medicaid, very low percent voted for Trump, to the dark blue, high percent covered by Medicaid, high percent voted for Trump, and then the pink and the teal mean other ends of the extreme. That sort of bluish in the middle is kind of the middle of everything. I don't know that I'm great at reading a multivariate map like this with more colors, but I certainly think it's interesting. And then, of course, you could use small multiples. So this is a small multiples graph that is about supporting school vouchers, and we're showing the religious affiliation and race, kind of weirdly, and then the income breakdowns, and then we have the percentage as the color on the map. So again, we're using the small multiples to show more variables. Next, I want to talk about projections. So projections aren't about mappings from the data to something on the physical page or the digital page, but they're very important when you are visualizing geographic data. So the reason why we need projections is because the world is not flat. The world, you can kind of imagine it as a sphere. It's not a perfect sphere, but you can kind of imagine it that way. And so you need to move from that sphere to something that you can visualize on a piece of paper or on a two-dimensional computer screen. And so there are a bunch of different strategies for doing these kinds of projections. One would be to sort of take a piece of paper and then kind of flatten the earth flat down onto it like that. There's conical projections where you sort of imagine you have a cone around the earth and you kind of imagine light coming out of the earth and casting the lines as shadows onto the cone. And then you could also think about it with a cylinder, a cylindrical projection, where you have a piece of paper wrapped around the earth or like a basketball, light shining out of the sphere, and then you look at the lines that get projected onto the piece of paper. So that's what we mean by projections. It's as if we're projecting the earth onto a piece of paper. And so here's a sort of visualization. If you think about a person, their head is also kind of like a sphere. And if you want to turn that into something in two-dimensional space, you're going to change something about the way that it looks based on that projection. So if you use a globular projection, maybe that is going to do the best in terms of maintaining the relationship between all the parts of the face. If you use an orthographic projection, that's going to make the bottom and top of the face look extra big, and maybe the middle of the face look kind of smooshed. If you have a stereographic projection, you're distorting it in another way. And then if you use a very common projection, which is called the Mercator projection, you can really see how that distorts the way that the head looks when it is on the paper. So here are just a few examples of map projections and applied to the United States. So the one that you probably see the most often is the Mercator projection. That's the one where the border with Canada looks basically completely flat across the top. So that's a sign that you're looking at a Mercator projection. An equal area projection, like from the US National Atlas, that's the one where you can sort of see a curve at the top of the United States. And this is trying to maintain the area of the states. And then we have a couple of other projections where we might see the United States rotated or flattened in some way. And of course, XKCD has a cartoon about map projections as well. So he has what your favorite map projection says about you. It starts with the Mercator projection. It says you're not really into maps. The Robinson projection, the Van der Grinten projection. There's a few projections here that are kind of strange, the Dymaxion and then the good Homolocine projection. Those don't turn into nice rectangles. They have these kind of strange shapes, but then they do a better job of preserving the shape and size of objects on the Earth. There's the equirectangular projection, platte carré, I guess. It says you think this one is fine. You like how X and Y map to latitude and longitude. The other projections overcomplicate things. You want me to stop asking about maps so you can enjoy dinner. There's a globe. Yes, you're very clever. Some strange projections down into here. I don't know much about the Gall-Peters projection, but it looks like that's one that is cutting off the poles and really extending the length of some of the continents. And apparently what that says about you is, I hate you. So different personality types based on map projections. And one of the implications of map projections is that they can make a particular part of the world look larger or smaller than it is in reality. And one of the things that gets sort of underemphasized in terms of its size is the continent of Africa. So, because of the way map projections often get centered on the United States or Europe, because they're kind of made in this Western centric, colonialist way, a lot of maps were developed during the colonial era, it is underrepresenting how large Africa is. So it looks smaller. And so this is a piece called The True Size of Africa, where you can see how a bunch of other countries fit inside Africa. So Africa is large enough that the United States, with Alaska and Hawaii, and all of China, and India, and Eastern Europe, and Italy, and Germany, and France, and Spain, and Japan all fit inside of it. So I think this is something that most people would not have realized based on the map projections that we see the most often. And I think I have you looking at a piece by Zan Armstrong, which shows similar things where you can compare the true size of different parts of the world to get a better sense of how they compare. And then I just had to include this sort of joke meme tweet from recently. Even if you're fully vaccinated, the CDC still recommends never using a Mercator projection for choropleth maps. And then the last thing that I want to talk about is the idea of humanizing maps. So to bring it back to this idea that the problem with maps is that the world looks like a map. And so when we look at a map, we think that it's true in some way. But just like with all other data visualizations, maps are embedding people's biases into them. And so all kinds of stuff about race and class get really embedded into maps. And I've seen a couple great attempts at humanizing maps. One piece that I really love is Jared Thorpe's St. Louis Map Room. So he did this project with a creative arts center. They would take like a Google map or some other, I think this is maybe a government created map of some area of St. Louis, and they would use a projector to project it down onto a piece of paper that was on the ground, basically. And then they invited groups of people, and in this case, I think it's school kids, to come in and kind of humanize the map by drawing landmarks or things that they knew about onto the map. I think in this case they've traced a bunch of the roads so that they can get that kind of base map, and then you can see some of the other maps are hung up in the background. So this is a way to really sort of put people back in control of the map, and let them do the labeling rather than having it come from a corporation or a government. And this is from Stephanie Evergreen's blog. The piece is called How Data Viz Can Unintentionally Perpetuate Inequality. And it's an example of a map of Ramsey County for African American participants in employment services. And it's kind of relating to poverty and race. And the original map is on the left-hand side, and then the redesigned map is on the right. And when the original map was shown to the people in Ramsey County, the African American people who are participating in employment services, they were really offended by the map. Because the color of red and the distribution of the dots, they said it made it look like they were an infestation. On this kind of neutral colored map, then you have this infestation over the map. And so the redesign decided not to show people as individual dots, but to aggregate them into these areas, make a choropleth map, and use purple, which is a more neutral color. So that was a more appropriate way to sort of make that map. Interestingly, it's moving away from dots as individuals and into this aggregated version. Oftentimes, I think that it's more humanizing to have a dot represent a person, but then there are great arguments for why it's actually better to sort of remove the specific person from the visualization. And then the last thing that I want you to think about as you move away from this section is it's very easy to make maps in a variety of different analysis softwares. And they're very compelling to people because people can find themselves on the map and then they can hopefully see themselves in the data. And so I think designers often, if they can find geographic information, they will make a map. But the question is, when are the cases when you have data that maybe has a geographic component, but a map is actually not the right choice, and you should actually use a different type of visualization? So I'd like you to contemplate that.